So now we're going to begin Chapter 2 on descriptive statistics. And remember, we already defined this previously as the branch of statistics where you try to figure out how to describe the important characteristics of your data. So in descriptive statistics, this is where you figure out how to organize, summarize it, and present it. We often organize our data using some sort of tables. We draw some pictures, come up with some sort of graphs, and then we calculate some sort of numerical summaries such as averages or percentages. But we're going to begin with organizing and presenting this data using tables and graphs. And we're also going to begin in section 2.1 with just looking at qualitative data. Because remember, I said the types of pictures you draw and the types of numbers you crunch depend on whether the data is qualitative or quantitative. So in section 2.1, we're looking at how to organize and present qualitative data. And the first thing we're going to look at is organizing the data into a table that is called a frequency distribution, or a variation of that called relative frequency distribution, and then coming up with the matching bar graph. So right now I'm going to revert to a PowerPoint which goes through all of these definitions but gives some examples, and then we'll go back and work this first example here from your notepad. So switching over to the PowerPoint. Again, what we're trying to do is figure out how to organize qualitative data, right? So we can do that with tables first, and then different types of graphs, bar charts, and pie charts, which I'm sure you're familiar with. Okay. So the first thing you're going to do when you get a pile of qualitative data, here's an example here of a part of a sample about what political party people belong to, so Democrat, Independent, Republican, so on and so forth. So envision you have 1,000 of these values, and you're trying to figure out what your data is trying to tell you. So the first thing is, well, why don't you take this qualitative data and organize it into a table? So this is going to be called a frequency distribution. So it is a table that first lists every category of data, sometimes we call it classes, and then counts up the number of occurrences that occur in each category, and that's what we call the frequency. So if you were going to organize this data set into a table, you'd come over here, and in the first column you would list all your choices for political party. So the possible categories are Democrat, Republican, Independent, and other. Then you would take the original data set and count up how many data values fell in each category. That's the frequencies. So here it said you have 372 Democrats, 300 Republicans, 504 Independents, 24 other. So immediately you're starting to organize your data and try to see what it's trying to tell you. So you can be looking at 1,000 raw data values, but the minute you organize it in a table, you can see, here most people answered Independent, followed by Democrat, and then Republican, and then very few said other. Okay, this type of table is called a frequency distribution. The first column, you label what the categories are, and the second column is the frequencies. Okay. Now, there is a variation of this where sometimes instead of saying how many values fell in each category, somebody says, well, why don't you switch that and tell me what proportion fell into each category or what percent. So that's a variation of a frequency distribution, and that is called a relative frequency distribution. So all it does is, again, it's another table. It lists each category of data, and then instead of the frequency, it has a proportion or a percent, right? So I'm sure all of you know how to compute a percent. If you want to know a percent that fell in each category, you would just set up a fraction where the denominator is, how many do you have altogether, and in the numerator, what's the frequency? Right? So that is also known as relative frequency. So here's an example of two distributions. One is a frequency distribution and the other one is relative frequency. So this is say how many students got particular grades in a course. Actually, I think this is a grade distribution for statistics college-wide in a recent semester. So this is qualitative data. So here's the category of grades, and how many got an A, B, C, D, F, and how many withdrew. So sometimes a frequency distribution is fine, but a lot of times when these numbers are large, it would be easier to interpret that data instead of having frequencies if you switched them to relative frequencies or a proportion or a percent. So here's the exact same data, but instead of frequency, it's relative frequency. So these have all been converted, and sometimes this is a little easier to interpret. You can see 32% got C's, 26% got B's, and so on and so forth. So these are both distributions. This one just is a frequency distribution, and this is a relative frequency distribution. The point of either one is to quickly glance at the table and start to see what the data is trying to tell you. Now, in addition to a table in statistics, we also want graphs to represent our data. So if you have either a frequency distribution or a relative frequency distribution, the matching graph is going to be, one type is a bar chart. So a bar graph is a vertical bar chart that represents either a frequency distribution or it could be a relative frequency distribution. So what you do is you set up your data values, go on the horizontal axis. So once again, here's political party, Democrat, Republican, Independent, and other. And then on the vertical axis is either frequency or relative frequency. And then what you do is you draw a bar for each category, and the height represents either the frequency or the relative frequency. And a lot of times a picture is a very good visual of what the data is trying to tell you. So here you can even see maybe a little better that the top category was Independent, Democrat, Republican, and then very few in others. And again, this vertical bar can either be frequencies or it could be relative frequencies. So one more slide here. Again, a frequency distribution, this is a table that organizes your data, and then here's the matching bar graph, right? So, and then the second variation of that is here is the same data. This is a frequency distribution, and this is relative frequency. Notice just looking at the graphs, they both give you the same picture. It's just here, the heights are the frequencies, and over here, the heights are the relative frequencies. All right, so that goes through all the definitions, but now we're going to work through an example on our own. All right, so here we have an example of qualitative data, and this is about blood groups. So the 4 blood groups are A, B, and O, and here's a sample of blood donors and the blood groups below. So this isn't a very large sample because we're doing this by hand, but what you want to do is, try to figure out what this data is trying to tell you. So the first thing we're going to do is organize it in a table, frequency distribution and a relative frequency distribution, and then we're just going to draw the matching bar graphs. And that's the direction here. So the first thing we're going to do is set up a frequency distribution. So here's our table, and you always want to label the categories, what they are. So this is going to be the blood groups, and then this is the frequency. And then your categories are A, B, and O. And then all you do is run through the data set and count up how many times you got each category. So if you went through here and counted up the A's, and I suggest you cross these off or make tabs because it's very easy to double count or miscount. So if you go through all of these, I think you'll find that there are 12 that were type A. And for B's, there's only, if we go through here, there's 3 of those. And for ABs, if you go through, there's only 1. And the most common here seems to be the O's. So if you carefully went through here and counted up all the O's, you would have 14. Okay, this is a frequency distribution that shows all the categories and how many times they all occurred. So now you can quickly, look at this table and say, well, O was the most common, followed by A, and then very few B's, and of course AB is very rare. One thing you always want to check is that the total's correct. So over here we can see that the sample size here is 30. By the way, the symbol for sample size in statistics is always the letter little n, so we know the sample size is 30. So one thing you should always check is that all these frequencies add up to your sample size, because it's very easy to come up short or double count something. So we always check, little math notation here, that the sum of these frequencies equals 30. This symbol here means if you add up all the frequencies, do you get the sample size? So that's the frequency distribution. Now let's say, notice here it also says, why don't you give a relative frequency distribution? So I'm not going to create a second separate table, I'm just going to add another column, and I'm going to say switch this to relative frequency. So remember, all that means is you're switching these frequencies to proportions or percents. So I'm sure you all know if you want to switch these to percentages, all you do is take each frequency and divide by the total. So the formula for this is for each category, frequency over the sample size. So you always start with a fraction. So this is 12 out of 30, but you're always going to switch this to a decimal. Now, one comment here, if you have to round, the first one here comes out even. As a proportion, this is 0.40. Now, I know everybody wants to interpret it as a percent, but you'll always start with a fraction, which then is going to be a decimal less than 1. If you want to switch it to percent, you multiply times 100% or move the decimal over 2 places. So this is the proportion, 0.40 or 40%. The next one, if you want to switch to a proportion, instead of 3, it's 3 out of 30. So that's a proportion of 0.10, or as a percent, 10%. Then you have 1 out of 30. Now, this doesn't come out even. This is 0.03333 repeating. So the question is, how many decimal places? Okay, if you think about rounding this to a percent, you would definitely want this to be accurate, to the nearest percent. So with that in mind, you would want to keep at least 2 decimal places here. So if you switched it to percent, it'd be accurate to the nearest whole number. So let's say you round this to 2 decimal places. So this would be approximately 0.03, and then as a decimal, it would be 3%. And the last one here, 14 out of 30. Again, this doesn't come out even, 0.46666. So if we round this to 2 decimal places, again, use the correct rounding rules. If the number next to it's more than 5, you round up. So this would be about 0.47 or 47%. Now, one thing about checking this is if you switch this to relative frequencies, if you add up all your relative frequencies, all your proportions should be very close to 1. And if you switched them to percents, they should be close to 100%. Now I say close because sometimes based on rounding, you might end up with, 0.99 or 1.01. That's okay. But if you're further than that away, it probably means you made a rounding error. So make sure when you check the number next to it, if it's less than 5, you don't round up, and if it's more than 5, you do. Okay, so now you have the blood groups in a table. You can look and see their frequencies and their relative frequencies. So now, if you were to draw the matching bar graphs, we're going to draw both. So all you do is, if we're doing this by hand, all right, the horizontal axis is always what the data represents. So this is going to be what blood group it is. And then over here, we're first going to do frequency, and then we'll switch to relative frequency. So I'm going to draw 4 bars, one for each blood group, and the height of the bar is going to be the frequency. So the first thing you need to do is draw a scale for this vertical axis. So how high do you need to go? The highest frequency is 14. So maybe you go 14 or a little higher, 15. So let's say I just say, all right, I'm going to go to 15. So 5, 10, 15. And then all you do is draw a bar for each category. So I'm just going to do these in the order they're in. So type A had a frequency of 12. Type B had a frequency of 3. AB only had a frequency of 1, and O had a frequency of 14. And the thing about a graph is it has to be labeled. It needs a title, and it definitely needs to have the axes labeled. So not only this labeled, you need to say what each bar represents. So this is AB, AB, and O. One comment here, it is absolutely fine to have gaps between the bars because these are qualitative data. It's not like I skipped a number or anything. So it is fine on qualitative data to have gaps. Okay. Now, if you wanted to do a relative frequency bar graph, then all you would do here is you would still come over here and set up the group, but on the vertical axis, you would put relative frequency instead of frequency. So now, as far as the height of the bars, and this is usually done with the relative frequency, not the percent. It's typically what you'll also see in software. So when you look over here and you say, all right, I've got 0.4, 0.10, 0.03, 0.47, so the highest one is 0.47. So let's say we go a little higher than that at 0.5. So now see what I'm doing here is I'm just changing this axis to be proportions instead of frequencies. But once again, you just draw a bar for each blood group, and the height of the bar is the relative frequency. So the first one here is 0.40, and then we have 0.10, and then we have 0.03, and the last one is 0.47. And once again, you label this A, B, A, B, and O. Now, obviously, it didn't matter whether you did frequency or relative frequency is finding the important features. You can still see the most common category is O, followed by A, and then the other two. So that's the basic idea behind qualitative data. You organize it in a table, either with frequencies or relative frequencies. The key here is make sure you label these columns, because if a table's not labeled, nobody knows what you're talking about. Matching graph here, bar chart, make sure you label the axes, label the scale.